We're going to begin section 6.1 and discuss the idea of an angle and also the idea of a radian or degree measurement of that angle. Let's begin with some key terms. We're first going to define a ray. You may remember a ray from a geometry class in the past. Recall that a ray is a part of a line that has a definite point on one end and continues in the opposite direction with an arrow. What we want to consider now is what happens if we have two rays that share the same point. For example, if I have a ray that extends out to the right, and then I draw a second ray, and remember they want to share the same point, so we're going to start it here as well, and I extend it in this direction. If you look at our picture, you can see that now we have what we commonly refer to as an angle. So one definition of an angle could be that it is two rays that share the same point. We now want to look at the idea of a positive angle versus a negative angle. Whether an angle is positive or negative depends on the direction that the rotation is moving in. For example, what we see in this first picture is we see an angle that is essentially closed. The one side of the angle and the other side of the angle, both of the rays lie directly on top of each other. If we take this top ray and we rotate it up, then we form what is referred to as a positive angle. And often you will see a smaller angle inside showing the direction that the angle was formed. And so this refers to a positive angle. We call this bottom side the initial side because this is where the angle started. And we call the side where it stopped the terminal side. Furthermore, let's look at the negative angle. Again, for the negative angle, we have both rays to begin with on top of each other. And so if we take our top ray and we rotate it in a down direction, we form an angle that we refer to as a negative angle. So the rotation went from here to here, and we refer to this as a negative angle because of that direction. Again, this will be our initial side because this is where the angle started, and this will be our terminal side because this is where the angle stopped. So again, if the angle rotates up, we're going to call it a positive angle, and if it rotates down, we'll refer to it as a negative angle. We next want to look at what it means for an angle to lie in standard position. So if you will consider your XY axis like you had in, say, an algebra class, an angle in standard position meets two criteria. The first is that the point lies on the origin. This point on the angle is referred to as the vertex of the angle, and the vertex must lie on the origin if the angle is going to be in standard position. The second criteria is that the initial side of the angle has to lie on the positive x-axis. So our initial side of the angle lies right here. If those two criteria are met, any angle that you draw is considered to be in standard position. Again, you need the vertex at the origin and the initial side of the angle on the positive x-axis. And so if I draw an angle here, for example, then that angle is said to be in standard position. Any angle that you have can be measured in terms of one of two systems. An angle can be measured in radians, or an angle can be measured in degrees. And when we talk about the measure of the angle, what we're referring to is how far it rotated. For example, this angle would have a smaller measure than, say, this angle, because here the rotation is greater. So the measurement refers to how far the angle rotated from the initial side to the terminal side. So again, the measurement of the angle can be talked about in one of two ways. One thing that you want to keep in mind is that these are equivalent ways to discuss an angle. Let me show you a quick example. For example, this angle, and this is hopefully one that we're all familiar with, this is a 90-degree angle. Now, we could also draw that exact same angle, but instead of calling it a 90-degree angle, we could call it an angle that has a measurement of pi over 2. 90 is a degree measurement, pi over 2 is a radian measurement, but they are exactly the same in terms of the angle that they describe. Notice that the angle is the same whether you're talking about it being 90 degrees or whether you're talking about it being pi over 2 radians. So one thing that we want to be able to do is to convert between these two systems. There are times when we have a degree measurement and we want to make it a radian measurement. And likewise, there are times when we have a radian measurement and we want to make it a degree measurement. To do this, we have a simple formula that we'll use. To convert from degrees to radians, we're going to multiply by pi divided by 180. And to convert from radians to degrees, we're going to multiply by the reciprocal. So we're going to multiply by 180 divided by pi. So with that in mind, let's look at a few examples. Our directions ask us to convert the following angle measurements as directed. So we start with pi over 3 radians, and we're asked to convert it to degrees. So remember that we're going to take our angle measurement, which is pi over 3, and if we want to convert to degrees, we're going to multiply by 180 divided by pi. So multiplying across the top of our fraction, we have 180 times pi. Multiplying across the bottom of our fraction, we have 3 pi. You'll see that your pi's will cancel. And 180 divided by 3 is 60 degrees. So a 60-degree angle could also be written as an angle that has a measurement of pi over 3 radians. Often students will find that they are more comfortable working a problem in degrees. And therefore, if the problem originates with a radian measurement, often students will convert it to degrees in order to make things a little bit easier. So that is one benefit of knowing how to convert an angle in radians to degrees. Let's look at our next example. It says express 270 degrees in radians. So 270 degrees Remember, to convert to radians, we're going to multiply by pi over 180. So again, we're going to multiply across the top, 270 pi. We're going to multiply across the bottom. Remember, there's a 1 sitting underneath that, so that will just be 180. And we're going to reduce our fraction. So 270 divided by 180 is going to be 3 over 2. And so we could say that an angle that has a measurement of 270 degrees is equivalent to an angle that has a measurement of 3 pi over 2 radians. You will find that often in an application problem or a word problem in our book, often the formulas require that the angles be in terms of radians. So in that case, if a problem gives you a degree measurement, but you need an angle in radians in order to use your formula, you must know how to convert it. Our last example asks us to express -2 radians in terms of degrees. So again, we'll take our -2 and we'll multiply by 180 over pi in order to convert to degrees. So we have -2 times 180, which is going to give me -360. We have pi times 1, which is going to give me pi. Now, you will find in most cases that the book would like you to go ahead and convert this to a decimal approximation. And so entering this in our calculator, -360 divided by pi is going to give me -114.592 degrees. And so again, -2 radians is equivalent to -114.592 degrees.